For this chapter, we're covering exponents and scientific notation. Our learning outcomes where we use the rules of exponents to simplify exponential expressions and use scientific notation. So this video is going to focus on the exponents. There'll be another one for scientific notation. So rules for exponents. Let's just say that we have x to the fourth times x to the third. So we have, this is x to the fourth here. This is x cubed. And so you have 4 of them, you have 3 of them, that makes 7 of them. And that's why we get x to the 7. Okay, there's blue, okay. So the product rule, this creates a product rule. A to the m times a to the n is a to the m plus n. And so we're going to write each of the following products with a single base. Do not simplify any further. So this is t to the 6th times t to the 9th is t to the 6 plus 9, which is t to the 15. So here we have negative 2 to the 4th times negative 2. There's no power showing, so that's to the 1 power. So that's going to be negative 2 to the 4 plus 1, which is negative 2 to the 5. And I got to keep those parentheses because it means something different if we don't have them. Now we have x to the 3rd times x to the 6th times x to the 2. So that's going to be x to the 3 plus 6 plus 2, or x to the 11th. Now in division, it's going to get to the quotient rule. If we have our y to the 7 over y to the 3, that's, they got 7 on top, 3 below. So these divide out. And we end up with 4 on top, so we get our y to the 4th. So that's our quotient rules. We can subtract the powers. For any numbers, real number a, and natural numbers m and n, such that m is greater than n, the quotient rule of exponents states that a to the m over a to the n is a to the m minus n. So let's look at these. Write each of the following products with a single base. Do not simplify any further. So this is going to be 3 to the 12 minus 5, or 3 to the 7. This is x to the 25 minus 12, or x to the 13. Here we have 3 times the square root of x to the 7 minus 2, because it's the same base. It's kind of a big base, but it's the same base. So it's 3 times the square root of x to the 5th power. Next, using the power rule of exponents, x to the 2 to the 3 is x to the 2 times x to the 2 times x to the 2. So if you use the product rule, we'd add those powers. So that's going to give us 6. The other way to look at it is, 2 times 3 is 6. So for any real number a and positive integers m and n, the power rule of exponents states that a to the m to the n is just a to the mn. So for our example 3, it's going to be x to the 3 times 5, or x to the 15. This next one is 2t to the 4 times 5, which is 2t to the 20th. And here we have negative 2 to the 4th to the 3rd, so 4 times 3, negative 2 to the 12. Now let's talk about negative exponents. 0 negative exponents. So in this case here, x cubed over x cubed, that'd be x to the 3 minus 3, which is x to the 0. But something divided by itself is 1, so this also equals 1. This leads to the 0 product exponent rule for exponents. For any non-zero real number a, the 0 exponent rule for exponents states that a to the 0 equals 1. Would have been nicer if I would have just hit got there. Yeah, it looks better that way. Okay, probably doesn't look like that on the PDF, so sorry. Simplify each of the expressions using the 0 exponent rule for exponents. So x to the 5th over x to the 5th, that's x to the 5 minus 5, which is x to the 0, which is 1. This would be negative 2x to the 7 minus 7, which is negative 2x to the 0, negative 2 times 1, which is negative 2. Here we have x squared y to the 6th power, and we're going to be subtracting a 2 and subtracting a 4. So it's x squared y to the 0, which is going to be 1. And here we have 7 times the quantity x squared y to the 5th power minus 5, which is 7 times x squared y to the 0, which is 7 times 1, which is 7. Now let's talk about negative exponents. So if we have x to the 4th over x to the 8th, so we have 4 on top, 8 on the bottom, these would divide out. Let me put the 1s, because it doesn't just disappear, there's actually 1 there. So we have 1 over x to the 4th, which is x to the negative 4th. So x to the 4th over x to the 8th is x to the 4 minus 8, which is x to the negative 4th, which is 1 over x to the 4th. So if you have a negative power, it goes below the fraction bar and becomes positive. And that's what this rule states. For any non-zero real number a and natural number n, the negative rule of exponents states that a to the negative n is 1 over a to the n. So we have b to the 3rd, b to the negative 5. Let's read the instructions. We want to write these answers as positive exponents only. So this is b to the 3 plus negative 5, b to the negative 2, or 1 over b squared. This would be negative x to the 4 plus negative 4, so negative x to the 0, which would be 1. And here we have negative 3x. The one on top has a power of 1, so 1 minus 4, negative 3x to the negative 3, or 1 over negative 3x cubed. So, and you probably could have, you probably saw it here and you're shouting at me like, why don't we just cancel this one here with that, leaves a 3. You could do that too. Okay, finding the power of a product. If you have a product raised to a power, that's like xy to the 4th. You got 4 of these xy's. Draw that better. So that means 4x is 4y, so it's x to the 4th, y to the 4th. So the power of a product rule states that for any real numbers a and b, and any integer n, the power of the product rule of exponents states that a b to the n is a to the n, b to the n. So we have a squared b to the 4th to the 3rd. So it's a squared, a to the 2 times 3, excuse me. B to the 4 times 3. So that's a to the 6th, b to the 12th. Next one, that's 3 to the 4th, t to the 4th. 3 to the 4th is 81, so 81 t to the 4th. Here we have negative 3 to the 3rd power, x to the 2 times 3. So it's negative 27 x to the 6th. Here we have 1 over negative 3 to the 5th power, x to the 5th power. So that's going to be 1 over, I believe that's negative 243 x to the 5th. And finally we have e to the negative 3 times 5, f to the 4 times 5. So it's e to the negative 15, f to the 20. So it's going to be f to the 20 over e to the 15 if we want positive exponents. Okay, our next topic is finding the power of a quotient. So in that last one we had e to the negative 3, f to the 4 to the 5th was f to the 20 over e to the 15th. Now consider if we had positive exponents. So instead of e to the negative 3, it was e to the 3rd down below. So f to the 4th over e to the 3rd to the 5th is f to the 4 times 5, e to the 3 times 5, so f to the 20 over e to the 15. Which brings us to the power of a quotient rule of exponents. A to the n over a over b to the n is a to the n over b to the n. So we have 3 squared over x to the 5 times 2, so 9 over x to the 10. This is m to the 5th over n to the 4 times 5. So it's m to the 5th over n to the 20th. Here, like negative 1 to the 22 power over x to the 2 times 22. Now negative 1 to an even number is just going to be 1. X to the 44. And then we have x squared, x to the 2 times 5, excuse me, y to the negative 3 times 5. So that's going to be x to the 10, y to the negative 15. But they want positive exponents, so it's going to be x to the 10 over y to the 15. And the next one, we have m to the negative 3 times 4, n to the negative 4 times 4. So it's m to the negative 12, n to the negative 16. But for positive exponents, it's going to be 1 over m to the 12th, n to the 16. Okay, let's go on to 18, where we simplify, 8. Simplify each expression and write the answer with positive exponents only. So we have 4 cubed, x to the 3 times 3, y to the negative 2 times 3. 4 cubed is 64. X to the 9th over, because that's going to be negative, y to the 6th. So here we have 19 to the 5th plus negative 3 plus negative 6. So it's 19 to the, that's 5 and negative 9, so negative 4. So I'm going to leave this as 1 over 19 to the 4. Okay, what do we have here? I might clean this up before I do the power. So I could bring this down and bring this up. So we have y times y on top over x on bottom to the 4th power. So it's y squared over x to the 4th. So we have y to the 8th over x to the 4th. Okay, this last one here. I have a negative 3, x squared, y to the negative 2, 4x negative 3, y to the 3. Negative 3 times 4 is negative 12. Then I have x to the 2 plus negative 3, y to the negative 2 plus 3. So negative 12, x to the negative 1, y to the 1. So it's negative 12y over x. Okay, I'm not sure why I keep circling the last one. Oh, there's 2 more here. Okay, and then we'll stop there for scientific notation. Here we have, these are the same base, x cubed times the cube root of 3. So this is going to be x cubed times the cube root of square root of 3, not cube root, of 5 plus negative 5. So it's going to be x cubed times the square root of 3 to the 0, so that's just 1. And finally, we have 2x to the 4th cube, so that's 2 cubed x to the 4 times 3 over 6 squared x to the negative 2 times 2. So I have 8 x to the 12th over 36 x to the negative 4. So right off, this 8 and this 36, they have a 4 in common, so I could divide that out. It leaves a 2 on top and 9 on bottom. So we have 2 over 9. Then we have x to the 12 minus negative 4. So 2x to the 16 over 9. We'll stop there. Well, we're almost at 15 minutes for this lesson. Okay, thank you.